Okay, welcome back. Here we go. Homework 24, sigma notation. If you are rusty with sigma notation, let's review below. I'm going to write this first one here a little bit bigger. Summation k equals 1, that's sigma notation, 1 to 5 of k. Well, I like to think of 1 here as your start point. It's like store 1 in for k. Store 1 in. Then store 2 in, 3 in, 4 in, and this is your stopping point. So if you want, just write note to self, start, stop. So you 1, 2, 3, 4, 5, right? You stored 1 in for k, record. Store 2 in for k, record. Store 3 in for k, record. But, what do you do to all those numbers? You see, you add them up. So for each term, and then the sigma is telling us to add up each term. So 1 plus 2, so then 1 plus 2 plus 3 plus 4 plus 5, and voila, we'll get 15. Okay? Now that, you just have to understand how to interpret the sigma notation. So the next one is a little small. I'll rewrite it. It's summation 1, k going from 1 to 3, of negative 1 to the k, and then times k. Well, again, just practice storing 1 in and then storing 2 in, and then your stopping point is 3, so storing 3 in for k. So if you store 1 in, negative 1 to the first power times 1, well, that result is going to be negative 1. Then store 2 in. Well, negative 1 squared is going to be 1. And then times 2, it's going to lead you to 2. And then, last but not least, store 3 in, and so negative, you can start to do it mentally, negative 1 cubed is negative 1, and then 3 times, and then times 3, so that's going to lead you to negative 3. So you can see where these terms are coming from. Negative 1 plus 2 minus 3, that's eventually going to lead you to negative 2. And so on and so forth. Okay? So once you familiarize yourself with these basics, you're ready to plow in and do this homework problem with me. So let's just jump in and do this homework over here together. I think that's probably the best thing to do because you can review that table on your own. Write the sum without sigma notation and then evaluate the sum. It says summation, I'll write it bigger again, summation k going from 1 to 2, and then you have 144k over k plus 7. Okay, so let's just start off by storing 1 in. If we store 1 in, we'll get 144 over 1 plus 7, which is 8. I'm even just going to write a comma. And then store 2 in. Well, whatever 144 times 2 over 2 plus 7, which is 9, whatever that may be, then you're eventually going to add those two things together. So you'll take this plus this and add it together. So I'll hit pause as we crunch that out. You can crunch it out in the calculator. So after all that sweat equity, 144 over 8 comes to be, oopsie, sorry, that's sliding around, comes to be 18, and this quantity comes to be 32, and 18 plus 32 is 50, and that is the answer we have posted in. So right over here you see I've pasted in the answer is 50. So just a little bit of reminders about language then. The index k starts at 1, that's your index starting at 1, goes to n, that's your stopping point, and a sub k is a formula for the kth term of the series. Alright, let's try the next problem. Okay, with this problem, we could do it the way we've been doing it by just storing numbers in, but I want to actually practice the algebraic rules for finite sums. Like, for example, the sum of two terms can be broken into two different sigmas. The difference rule, so the summation of a difference can be broken into two different summations as well, etc., etc. But let's go ahead and clean up the argument in here. So we'll have summation k going from 1 to 6 of 3k squared plus 4k. Now, according to these algebraic rules, we could rewrite this as summation k going from 1 to 6 of 3k squared plus summation k going from 1 to 6 of 4k. Then according to the constant multiple rule, I can pull those sort of coefficients out front. So we can call that 3 summation k squared, k going from 1 to 6. And we can call that 4 summation k, k going from 1 to 6. Then we can start to apply some very famous rules, like the sum of the first n integers from 1 to n. This is a very famous one, the Gauss one, is n times n plus 1 over 2. So we know this will come to be 6 times 6 plus 1 over 2. Note to self, Gauss, I think he came up with that when he was pretty little, which is amazing. But yeah, just remember some of those famous summations. So summation 1 to n of k is n times n plus 1 over 2. I'll hit pause as we continue crunching that out. So I kind of wrote it larger here on the next slide. So again, the summation from 1 to 6 of k is 6 times 6 plus 1 over 2. So if we crank that out, 6 plus 1 is 7, times 6 is 42, divided by 2 is 21, so we'll have basically 4 times 21 over here. This is another famous one. So the sum of the squares, the sum of the squares of the first n integers is given by n times n plus 1 times 2n plus 1 over 6. So that's another famous one. So, and I'm just going to speak that out, n times n plus 1, so times 6 plus 1, where this is your n, times 2n plus 1, well 2 times 6 is 12, so 12 plus 1, all over 6. Okay, so if we crank that out, 12 plus 1 is 13, 6 plus 1 is 7, and 7 times 13 is a 91. These 6's here will cancel, so we'll have 3 times 91. I'll hit pause. So we crank that out. 3 times 91 will come to be 273. 4 times 21 will come to be 84, and that'll bring us to 357. So if you go back to the previous slide, you'll see that I have some little hints and things pasted in here for you to remember some of those very special summations. All right, I think we have one more homework problem. Let's check that out. So in this last homework problem, it says, obviously I did this one on my math lab myself, and I have the right answer circled, that all of these are the right answer. It says, which of the following express this in sigma notation? So let's just kind of do sort of process of elimination, okay? Let's start with this first one, k equals 1. And, just really try it. Trial by fire, right? Store 1 in. So let's look at the answer to A. It says summation k going from 1 to 6, and then it says of 4 to the k minus 1. Store 1 in for k and see what happens. Then you'd have 4 to the 1 minus 1, which is 4 to the 0, which is clearly 1. Then store 2 in. You'd have 4 to the 2 minus 1, which is 4 to the 1, which is 4. And then store 3 in. 3 minus 1 is 2, 4 squared is 16. But aha, if you keep going and so on and so forth, and if you store the last value in, which is 6, I'm just going to write ... 6 minus 1 is 5, and 4 to the 5th power is a very large number, 1024. So what you can, 1024. So what you can do is investigate that you would get these very same terms that exist in that summation. So this one works. And then you say, okay, well, let me try the other one. Summation k. So basically the index, this index starts at 1, goes to 6. This one starts at 0, goes to 5. But, you know, they could lead you to the same spot. And your term here, 4 to the k, well, you know, let's put 0 in. 4 to the 0 is 1. And let's put 1 in. 4 to the 1 is 4. Put 2 in. 4 squared is 16. Put 3 in. 4 cubed is 64. Put 4 in. 256. Put 5 in. 4 to the 5th is 1024. So no matter what, you know, you're using this expression, you're still getting that summation. And then I'll let you try, last but not least, that one is going to lead you to the same answer as well. So what I'm getting at is there's more than one way to express a particular series. Can be more than one right answer. Gotta love when that happens. All right, good luck out there, guys. I think that's the last homework problem. Let me double check. Yep, that's it for today. Good luck.